The universe is a vast, enigmatic space that has captivated humanity for centuries with its myriad wonders. Galaxies, giant structures composed of billions of stars, gas, and dust, are one of these unsolved mysteries. The scientific community has been rocked by a groundbreaking discovery made by the James Webb Space Telescope, JWST, in recent times. Michio Kaku, a renowned physicist who is well known for his innovative ideas and capacity to explain intricate scientific concepts, contributed to this finding. He featured changing comprehension we might interpret the universe potential. 6 massive galaxies, contrary to current theories, were discovered by JWST. The foundation of our understanding of the early universe and the formation of galaxies is cast into doubt by this finding. At the point when the information from JWST showed up in the control room, researchers were loaded up with amazement and mistrust. These were not your typical galaxies, as evidenced by the extraordinary information and images shown on the screens. They were massive, ancient galaxies that raised questions about how the universe came to be. The room hummed with energy and doubt as the group understood the meaning of their disclosure. The world is about to undergo a paradigm shift in our understanding of the universe due to the profound implications. A shocking discovery has been made by JWST, a modern engineering marvel that succeeds the Hubble Space Telescope. Just 200 to 700 million years after the Big Bang, 6 massive galaxies from the universe's earliest times were discovered. Despite their formation at a time when the universe was still in its infancy, each of these galaxies contains more stars than our own Milky Way. Scientists must reevaluate the established chronology and mechanisms of galaxy formation because the size and brightness of these galaxies pose a challenge to existing models of cosmic evolution. JWST addresses a huge forward-moving step in cosmic perception innovation. JWST observes the universe in the infrared spectrum, in contrast to Hubble, which operates primarily in the visible spectrum. It can do this by peering into dense clouds of gas and dust, giving a better picture of the beginning of the universe. JWST's essential mirror, 6.5 meters in distance across, comprises of 18 hexagonal sections made of beryllium and covered with gold. The telescope can gather more light and produce images with a higher resolution thanks to this design. Moreover, JWST is furnished with a tennis court-sized covering that shields its instruments from the sun's intensity and keeps up with the very low temperatures required for infrared perceptions. The Near-Infrared Camera (NIR-CAM), the Near-Infrared Spectrograph (NIR-SPEC), the Mid-Infrared Instrument (MIRI), and the Fine Guidance Sensor / Near-Infrared Imager and Slitless Spectrograph (FGS/NIRIS) are just a few of the instruments that the telescope has to offer. From studying exoplanets and looking for signs of life to the formation of stars and galaxies, these instruments work together to provide a comprehensive view of the universe. The JWST telescope's capabilities and the dedication of its operators can be seen in the discovery of these 6 massive galaxies. These galaxies, also known as cosmic smashers, are from a time when the universe was just 200 to 700 million years old. As per current cosmological models, it would have been beyond the realm of possibilities for such enormous systems to frame so from the get-go in the universe's set of experiences. In stark contrast to the Milky Way, where star formation is more sporadic, each of these galaxies appears to be forming hundreds of new stars annually and contain more stars than the Milky Way. This disclosure challenges the laid-out course of events of infinite advancement, recommending that the development of huge, complex designs like cosmic systems might have happened significantly sooner than recently suspected. Scientists are forced to reevaluate their understanding of how galaxies form and the universe's evolution over time as a result of the revelation. These galaxies' early existence suggests that the processes governing galaxy formation may be more effective and quicker than previously thought. This difficulties the customary view that worlds develop bit by bit north of billions of years through the gradual addition of more modest articles and consolidations with different universes. The revelation additionally brings up issues about the age of the universe. If these massive galaxies form so quickly, it could mean that the universe is older than currently thought or that the processes of making galaxies started much earlier than previously thought. These findings have implications that go beyond cosmology and into fundamental physics. The disclosure powers researchers to re-examine laid-out hypotheses about the early universe, including the theory of how things came to be. The discovery of these first massive galaxies complicates this hypothesis and suggests that additional factors may have been involved, despite the fact that the hypothesis is supported by observational evidence like the redshift of distant galaxies and the background radiation from cosmic microwaves. A physicist of American and Japanese descent, Michio Kaku is well known for his contributions to quantum mechanics and classical experimental physics. Kaku, in contrast to some of his more conservative co-workers, was open to the unexpected outcomes of the JWST mission. Kaku acknowledged the possibility of these findings opening up new dimensions in our scientific understanding of the universe and described the discovery as one of the highlights of his interest. His excitement was obvious in his remarks on the extraordinary idea of the JWST perceptions and their suggestions for the eventual fate of physical science and cosmology. Kaku's profound knowledge of quantum mechanics and classical physics shaped his perspective on the cosmos. He has long upheld that how we might interpret the universe is inadequate and that new disclosures will proceed to challenge and grow our insight. Kaku accepts that the universe is substantially more intricate and baffling than we can right now comprehend, and he has devoted his vocation to revealing these secrets and clarifying them for people in general. Kaku is open to the JWST's findings because he thinks that new ideas and a willingness to change theories based on new evidence are essential to scientific progress. He frequently emphasizes the significance of maintaining an open mind and being willing to question preconceived notions in the face of new data. This approach is fundamental for the progression of science as it constantly refines and works on how we might interpret the regular world. Kaku stressed that the disclosure of 6 Goliath cosmic systems can possibly reform how we might interpret the universe. The timeline that has been established for the evolution of the universe is called into question by these findings, which suggests that the processes that lead to the formation of galaxies might be more effective and happen more quickly than was previously thought. This has significant ramifications for how we might interpret the early universe and the systems that molded its turn of events. Kaku accepts that JWST's discoveries will provoke a reassessment of current cosmological hypotheses and models.